Alrighty, we'll go ahead and start the session here. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, let me make sure I've got things going on here. Recording is going, should be on the right screen. So what we're going to look at today, first of all, we're going to cover material from the first test that we took, and then we'll go back and look at the second test. So let's get started here. Okay. So looking at the WebAssign screen, we see the problem that says graph the inequality x minus y is less than 4. Okay, so we've got x minus y is less than 4. So we're going to graph a single linear inequality. The first thing we're going to do is take a look at the related equation, x minus y equals 4. Then we're going to come up with a couple of points that are solutions to the graph of that linear equation. And I'm going to go ahead and use the x and y intercepts. So to find the x-intercept, I'll set y equal to 0. X minus 0 equals 4. So x equals 4. To find the y-intercept, set x equal to 0. 0 minus y equals 4. Negative y equals 4. Divide both sides by -1. And y equals -4. So now we've got two ordered pairs that are solutions to the equation. Now, we're going to go over to graph it on the WebAssign screen. And we're graphing a linear inequality. So I click on that until it turns blue. Let's see, my scale is 1 square is 1 unit. 4, 0 is there. 0, -4 is there. But my actual inequality does not include an equal sign, so I'm going to want a dashed line. But now I need to figure out which side of the line am I on, the top or above or below. I'm going to pick a test point. I'm going to go with 0, 0. So let's take the test point, 0, 0, and plug it into the original inequality. That is true. So the point 0, 0 is part of the solution. So we're going to fill or shade it. And on this side, whoops, and that should be the correct answer. And it is. All right, let's take a look at another example. Let's see, let's take a look at this one. All right. So this takes us to section, what is it, 4.5. That last one was out of 3.7. Solve the system of inequalities. All right. So the first one, we have 7x plus 5y less than 35. So let's take a look at the related equation. 7x plus 5y equals 35. Once again, I'm going to go after the x and y intercepts. I don't have to use those points, but they're nice points to use. So if y is 0, we get, let's see, we get 7x plus 5 times 0 equals 35. 7x equals 35, divide both sides by 7, x equals 5. If x is 0, we get 7 times 0 plus 5y equals 35. 5y equals 35, y equals 7. All right, so turning that blue, we're going to go 5, 0 and 0, 7. Okay, now that does not include the equal sign. So it's going to be a dashed line. Let's use 0, 0 as a test point. 7 times 0 plus 5 times 0 less than 35. 0 less than 35, that's true. So I would fill it on that side. Okay, so that's the solution to just that first inequality. But there's a second inequality we need to graph. So let's take a look at it. And that is 5x minus y greater than 5. The related equation would be 5x minus y equals 5. And again, I'm going to use the x and y intercepts. If y is 0, I get 5x minus 0 equals 5. 5x equals 5, x equals 1. To find the y-intercept, set x equal to 0. 5 times 0 minus y equals 5. Negative y equals 5. Divide both sides by negative 1. Y equals negative 5. Okay, so let's see here. We're going to graph a second line. Oops. Notice when I do that, the shading goes away. So you know what? Let's go back for a minute. And let's look at where that fill was. It was down below, wasn't it? So it was down here, just to remind us. Okay, let's go on to the second line now. So we've got 1, 0, and 0, negative 5. All right. This one also does not include equals, so it would be a dashed line. Okay. Now, which side of the dashed line are we on? Well, again, let's pick 0, 0 as a test point. Remember, a test point can be any point that's not on the actual line. 0, 0 is an easy one to deal with. So test point 0, 0, 5 times 0 minus 0 greater than 5, 0 greater than 5. That is not true. So instead of it being over here, it would be on the other side. So it would be basically over here. Okay. All right. So now let's go back to getting rid of all of the fill. For the first inequality, it was down here. For the second inequality, it was over here. So where do those two overlap? In this single area right there. So that should be the correct solution. Let's see if it is. Okay. Well, I'd ask if there's any questions, but there's nobody else here at the moment, so I won't ask. And now let's take a look at some stuff from chapter 14. Okay, 14.1 was factorials. So let's see, we've got 6 factorial over 4 factorial. Recall that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 0 factorial equals the number 1. I could take this and write it as 6 times 5 times 4 factorial over 4 factorial. I could then come in and reduce down the 4 factorials to 1 over 1. 6 times 5 times 1 over 1 is 30. So our answer should be 30. All right, let's take a look at the next one. Let's see, problem number 6 there. It says evaluate the expression 6 factorial over 2 factorial times the quantity 6 minus 2 factorial. Well, first of all, let's simplify what's inside the parentheses. 6 minus 2 is 4 factorial. I can do the same thing I did on the last problem, and that is I can write 6 factorial as 6 times 5 times 4 factorial. And on the bottom, 2 factorial times 4 factorial. Now I can come in and reduce out the 4 factorials. So I've got what? 6 times 5 is 30 over 2 factorial, which is 2 times 1. 30 over 2 is 15. So, okay. And let's see, let's take a look at this one, number 8. 14 factorial over 13 factorial would be 14 times 13 factorial over 13 factorial. The 13 factorials would reduce down, and our final answer is just 14. Okay, now this takes us to section 14.2, which was arithmetic sequences. Okay, now if they give you a specific sequence, such as in problem number 9, we follow that. If they don't, then we'll follow the one in the book, and we'll get there in a minute. So in problem 9, it says find the first 4 terms of the sequence defined by a sub n equals 4n minus 7. Okay, and we are to find a sub 1, a sub 2, a sub 3, and a sub 4. And separate those by a comma. Okay, so a sub 1 would be 4 times 1 minus 7, which is 4 minus 7, which is -3. A sub 2 would be 4 times 2 minus 7, which is 8 minus 7, or +1. A sub 3 would be 4 times 3 minus 7, which is 12 minus 7, which is 5. And a sub 4 would be 4 times 4 minus 7, which is 16 minus 7, which is 9. Again, in each case, I'm following this sequence. So let's see here. Our answers would be -3, comma, space 1, comma, space 5, comma, space, and 9. And let's see if that is correct. And it is. Okay, let's take a look at this next problem. Problem number 10. The first 3 terms of an arithmetic sequence are 9, -9, and -27. Find the 101st term. Now, in this case, they don't give us a specific sequence, so we're going to use the one that says, whoops, a sub n equals a sub 1 plus the quantity n minus 1 times d. Recall that a sub 1 is the first term, n is the subscript on a given term, and d is the common difference. So we know that a sub 1 is 9, a sub 2 is -9, and a sub 3 is -27, and we want to find a sub 101. Okay, well, we could find the common difference by taking any term in the arithmetic sequence minus the previous term. So how about if we take a2 minus a1? That would be -9 minus 9, which is -18. Tell you what, just to make sure, let's take a3 minus a2. That's -27 minus -9, which is -27 plus 9, which is -18. Okay, so the common difference is -18. We've established that. We know D, we know the first term. So a sub 101 is going to be the first term, which is 9, plus n, which is 101 minus 1, times the common difference D. So now we get a sub 101 equals 9 plus 101 minus 1 would be 100 times -18 would be 9 plus -1800, which is -1791, I do believe. All right. let's plug that in and see what happens. Negative 1, comma, 7, 9, 1. All righty. Let's see here. How much time? We've got lots of time. We'll keep going here. Okay, let's take a look at this next one. Find the common difference D of an arithmetic sequence if its first term is negative 593 and the 23rd term is negative 747. Okay, so again, we're going to use this arithmetic sequence A sub n equals A sub 1 plus the quantity n minus 1 times D. Okay. We know that A sub 1 is negative 593, and we know that A sub 23 is negative 747. Okay, and we're trying to find D, the common difference. Well, let's see. We know that A sub 23 equals A sub 1, which is negative 593, plus n minus 1, which is 23 minus 1 times D. So therefore, A sub 23 is negative 593 plus 22D. But we also know that A sub 23 is negative 747. So that means that this equals that because they're both A sub 23. So that gives us our equation. Negative 593 plus 22D equals negative 747. We're going to add 593 to both sides of the equation. So let's see what we've got here. We've got negative 747 plus 593, and that becomes negative 154. Then we'll divide both sides by 22, and we get negative 7. So let's see if that's true. Negative 7. And there you go. All right, let's take a look at the next problem. It says, find two arithmetic means between 2 and 31. So again, we're going to use A sub n equals A sub 1 plus the quantity n minus 1 times D. We know that A sub 1 is 2, all right? And then A sub something is 31. Well, if we're going to have two arithmetic means between them, that means that A sub 2 and A sub 3 would be the two arithmetic means between 2 and 31. Okay. Well, now the problem is basically like the previous one. We know A sub 1, we know A sub 4, we just need to find D. So we can say A sub 4 is A sub 1, 2 plus n, which is 4 minus 1 times D. So A sub 4 is 2 plus 3D. But we also know that A sub 4 is 31. So 2 plus 3D equals 31. We'll subtract 2. 3D equals 29. Divide by 3, and D equals 29 thirds. Oh. Okay, now, let's see. Have I made any mistakes? Because I'm thinking, oh, that's just not a very nice number at all, is it? Well, I don't think so, but this is a good thing to remind us of this, okay? We don't want to use mixed numbers in WebAssign. So the common difference is 29 thirds. So A sub 2 would be A sub 1 plus 29 thirds. Well, I need to take 2 plus 29 thirds and write it as a single number, which in this case is going to be an improper fraction. Okay, So 2 over 1 plus 29 thirds is what over 3 plus 29 thirds? Well, I would multiply 2 over 1 by 3 over 3, and I'd get 6 thirds plus 29 thirds is 35 thirds. Okay. Now, a sub 3 is going to be a sub 2 plus 29 thirds, which is what, 64 thirds. If this is correct, a sub 4 should be 64 thirds, oops, plus, let's erase that here. Plus 60, whoops, it should be 64 thirds plus 29 thirds, which is 93 thirds, which is 31. So it checks. Now, we're just supposed to put the two arithmetic means in there, which would be these two numbers. Okay, so my first one is going to be 35 thirds, 35 divided by 3. Now, if I do this, it's going to mark it wrong. What I've got to do is I've got to use the right arrow and get outside of the fraction, and then put in a comma and a space, and then 64 thirds. Okay. Again, let me show you if I do this, what happens. So this is a common mistake. Okay. So we go 35 thirds, comma, and then I go over here in a space and 64 thirds, and WebAssign doesn't recognize that comma. It thinks it's part of the fraction. Okay, so that's why we've got to be careful to do the correct notation concerning commas. All right. That takes us to section 14.3, which is geometric sequences. So here again, if they give us a specific sequence, we use that. If they don't, we use this. A sub n equals what? A, oops, 1 times r to the n minus 1 power. Okay, and r is the common ratio. So a sub 1 times r is a sub 2, a sub 2 times r is a sub 3. Here they say the first term is 1/27th, and the common ratio is 3. So the sixth term, a sub 6, is going to be a sub 1/127th, times 3 raised to the 6 minus 1 power, which is 1/27th times 3 to the 5th. Now, 27 is 3 cubed, right? So I could write this like this, which would be that, which would be that, right? Because 3 to the 5th divided by 3 to the 3rd, dividing two powers with the same base, subtract the bottom exponent from the top, and let's see if we get the right answer. And we do. Okay, let's take a look at the next one. Write the first 5 terms of a geometric sequence whose 4th term is 11 and whose 5th term is 11 halves. Okay, so a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. We know that the 4th term is 11 and the 5th term is 11 halves. Geometric sequence, so a sub n equals a sub 1 times r to the n minus 1 power. Okay. Now, we're supposed to find the first 5 terms. With arithmetic sequences, to find d, the common difference, you take any term in the sequence, minus the previous term. With a geometric sequence to find R, the common ratio, you take any term in the sequence divided by the previous term. So let's take a sub 5 divided by a sub 4, which would be 11 halves divided by 11, which is 11 halves divided by 11, which is 11 halves times 1 over 11, which is 1/2. So the common ratio is 1/2. Just to check it, if I take a sub 4, 11 times 1/2, I get a sub 5, right? Okay, but the problem now is we're going backwards. We need to go this way instead of this way, okay? Well, if going in this direction, we take, say, a sub 4 times 1/2 and get a sub 5, going backwards, we would divide. So a sub 5 divided by a sub, or a sub 5 divided by 1/2 is a sub 4, okay? A sub 5 divided by 1/2 is a sub 4. A sub 4 divided by 1/2 is a sub 3. Oh, dividing by 1/2 is just like multiplying by 2, isn't it? So this is going to be what, 44 and 88? Following that? So let's see, find the first 5 terms, separate them by a comma. So we've got 88, comma, space, 44, comma, space, 22, comma, space, 11, comma, space, 11 has. Again, it did ask for all 5 of them. Okay, let's take a look at this one. Find the first term of a geometric sequence if it has a common ratio of -4 and the 9th term is 1024. So we need to find a sub 1. And what do we know? We know that a sub 9 is 1024. And we know that R is -4, the common ratio. So a sub n equals a sub 1 times R to the n minus 1 power. Okay. Find the first term. Well, let's see. What do we know? Using the formula, we know that a sub 9 equals a sub 1 times -4 to the 9 minus 1 power, which is a sub 1 times -4 to the 8th power. So a sub 9 equals a sub 1. Let's see. If I take the quantity -4 and raise it to the 8th power, I get 65,536. Now be careful, you've got to put parentheses around the -4. If you just put -4 to the 8th, that's 4 to the 8th with a negative sign. You've got to quantify the negative base to make it come out correctly. Okay, so a sub 9 equals a sub 1 times 65,536. But a sub 9 also equals 1024. Therefore, this equals that. So a sub 1 times 65,536 equals 1024. I'm going to divide both sides by 65,536. Let's see if that comes out nicely. 1024 divided by 65,536. I get 0.015625. I wonder what that would be as a fraction. Put that in. Let's see what happens. Let's see if that works out. 0.015625. Okay. Now that's correct because it's an exact decimal. It didn't keep repeating or anything. But what if I wanted to write it as a fraction? How can I reduce this thing down? Well, let's see. What's common to this that's also common to that? I can see that 4 goes into both. Or if you're not even seeing that, you can just divide each of them by 2. Okay, this might take a while though. Half of 1,024 is 512. And then what if you take 65,536 divided by 2? That's 32,768. Well, then divide by 2 again. 512 divided by 2 is 256. And then 32,768 divided by 2 is 16,384. Wow, you know, this could go on a long time. Let's see, 256 divided by 2 is 128. 16,384 divided by 2 is 8,192. Then we get 64. And this could just continue and continue and continue. I'm going to stop there because it works as a decimal. But if this had been some repeating or continuous running decimal, not an exact one, then it would have had to do what I'm trying to do here. But it's taking forever. I'm going to abandon it. All right, let's take a look at problem number 16. Find two geometric means between -8 and 512. So a sub 1 is -8. Then we've got two geometric means, and then a sub 4 is 512. Okay. So a sub n equals a sub 1 r to the n minus 1 power. A sub 4 is -8 times r to the 4 minus 1 power. So a sub 4 equals -8 times r cubed, but a sub 4 also equals 512. So -8 r cubed equals 512. Divide both sides by -8, r cubed equals, let's see here, 512 divided by -8 is -64. Take the cube root, and we get -4. So -8 times -4 is 32. 32 times -4 is -128. -128 times -4 is 512. So the two geometric means are 32 and -128. Okay. Well, I'm going to go ahead and stop the recording, and then I'll take a quick break. I'll come back and we'll take a look at chapter 5. So I'm going to stop sharing.